Let's now do B. So I did A on my previous video. You can go watch it first before you tackle B. Right, calculate the magnitude of DAB. So it's D, then we go to A, then B. Right, the angle, the whole angle of A, it is the angle DAB, this angle here, meaning this angle is made up of A1 and A2, right? So we need the magnitude of that angle. Remember, in analytical grade 11, grade 12, we are tackling what we call the angle of inclination, right? The angle of inclination, right? So if a line is like this, if a line is like this, so here I'm talking about this line here. That will be the obtuse, because our gradient, if you look at this line here, the straight line, this one has a negative gradient, right? It's a decreasing y, then we're going to have an obtuse angle, an obtuse greater than 90. If the line was going up like an increasing function, we're gonna have this as as our angle of inclination. So let's put that on our diagram. So this one here, we see that this line here, if like it was to continue, it was gonna be like this, and our angle of inclination is this one, right? Then for this one here, AD, our angle of inclination is this one. So we need the gradient. So let's solve now. So what is the gradient of that line here? AB, the gradient of line AB. Okay, first of all, we need we need the gradient, right? So we know the coordinates of B are given as -1 and 5, right? I've calculated 5 on my previous video. This P is 5. Then what are the coordinates of A? Do we know the coordinates of A? Do we know the coordinates of A? I think we don't, so we can find the coordinates of A. So by using this equation, this line here, y is equal to -2x minus 3, we can find okay, first of all, we know that A lies on this horizontal x-axis here. That means the value of y is 0. So because that's the x-axis, so we need to find the value of x, right? So we can just substitute here. We know y is 0, then we have -3, not -3, -2 x minus 3, right? So for my handwriting, let me start. 0 is equal to -2 x minus 3. You can just take 2x to the other side. 2x is equal to positive -3, sorry. Then you divide, you get x is equal to -3 over 2. So that is the coordinate at A. 3 over 2, but negative and 0. So meaning now we just need to find the gradient of this line AB, right? So I'm going to say the gradient of AB. Remember, the gradient is given by y2 minus y1 over x2 minus y1. So this is the formula, over x2 minus x1, right? So y2, let me pick up the values here at the coordinate B. So at point B, so my y, we know it's 5, then minus into what is my x1. Let me just take it is -3 over 2, right? All over what is my x1 there, it is -1. Okay, sorry, this is my x, not my y. I'm going to submit here. I'm going to erase. So my y2 there at A is 0. So therefore my m is getting +10. So that is my m, right? That means the angle of inclination, remember the formula is tan theta is equal to the gradient. What is the gradient? M. So but we know tan theta is the angle of inclination, guys. This one is tan m. Therefore theta is equal to tan inverse of 10. What is tan inverse of 10? Punch it into my calculator. Shift tan, then 10. I'm getting 93.65. 93.65. So that means this one here, it is 93.65. Please do the calculate the angle of inclination for A1 here. We know A2 is 93.65. Please calculate A2. How do you do that? By you already have the gradient here. That means you are going to say tan shift. You're going to say shortcut. You're going to say theta is equal to tan inverse of negative 2, that is your gradient. Then you get the answer. So tan inverse of negative 2, but don't put the negative. Let's leave the negative now. So that gives you let me just remove the negative. That gives you 70.48. right? So we know A1 is 70.48. So this is an acute angle, guys. This is an acute angle, but remember, we want this one is a decreasing function, right? So we don't want this, guys. We don't want this angle. We only want A1. That is our acute there being 70. Then therefore our angle of inclination will be A1 plus A2, 70 plus 93 something 65.